Welcome to the unveiling of Project Chronoport Lenticularis, the next leap in dimensional aerospace engineering. This saucer is not just a vessel, it's a bridge between realms, designed to generate and modulate the precise quantum signals required for bidirectional slipstream travel. Drawing on the diaphane's metaphora framework, the Chronoport Lenticularis integrates advanced time-locking systems, entanglement pulse emitters, and a lenticular hull optimized for dimensional lensing. In this video, we'll explore the core subsystems, operational logic, and the science that makes this craft a true portal pioneer. Let's begin our journey into the mechanics of time-synchronized teleportation. Saucer's lenticular hull is more than an aesthetic choice, it's a functional marvel. Its curved, lens-like geometry is engineered to focus and refract quantum signals, enabling the craft to interact seamlessly with dimensional slipstreams. The hull's surface is embedded with quantum metamaterials, supporting robust entanglement fields and minimizing decoherence. This design not only enhances aerodynamic stability, but also serves as a dynamic interface for the portal's inflation and deflation phases. As we examine the hull's structure, notice how every contour is optimized for both physical and quantum performance, ensuring the vessel's integrity during high-energy transitions. The heart of the Chronoport Lenticularis lies its signal emitter array. This subsystem is responsible for generating the quantum pulses and echo harmonics that synchronize the saucer with the dimensional portal. Each emitter is calibrated to produce entanglement-compatible frequencies, ensuring stable bidirectional communication with the port-hole interface. The array's modular design allows for real-time adjustments, adapting to variable time zone locks and environmental fluctuations. This flexibility is crucial for maintaining coherence during both entry and exit, making the emitter array a cornerstone of the saucer's operational reliability. Time-locking core is the Chronoport's temporal anchor. This subsystem manages both fixed and variable time zone synchronization, allowing the saucer to lock onto specific temporal coordinates during slipstream transit. By modulating internal clocks and phase references, the core ensures that the vessel remains in perfect sync with the port-hole's inflation-deflation cycles. This precision is vital for safe and reversible travel, preventing temporal drift or misalignment. Time-locking core's integration with the emitter array and hull systems forms a unified control architecture, balancing quantum and classical signals for seamless operation. Dimensional hull overlay provides an extra layer of quantum shielding and signal modulation. This subsystem is composed of advanced 2D materials and topological insulators, forming a protective barrier against decoherence and environmental noise. The overlay's dynamic properties allow it to adjust in real time, responding to fluctuations in the entanglement field and slipstream conditions. This adaptability not only preserves the saucer's structural integrity, but also enhances the fidelity of portal transitions. The hull overlay is a testament to the fusion of materials science and quantum engineering at the heart of the Chronoport Lenticularis. Subsystem integration is where the Chronoport Lenticularis truly comes to life. Each core component, the hull, emitter array, time-locking core, and dimensional overlay, works in concert, orchestrated by a central quantum classical control unit. This integration ensures that every phase of portal engagement, from initialization to bidirectional transit, is executed with precision. The control system continuously monitors energy bands, temporal thresholds, and entanglement coherence, making real-time adjustments as needed. This holistic approach is essential for maintaining operational stability and maximizing the saucer's teleportation capabilities. Before any slipstream transit can occur, the saucer's quantum initialization protocol must be engaged. This involves activating the entanglement field, synchronizing the saucer's internal lattice with the target portal coordinates. The process is highly sensitive, requiring precise calibration of the emitter array and time-locking core. Once initialized, the saucer is enveloped in a stable quantum field, ready for dimensional deflation and entry into the slipstream. This stage is critical for ensuring that the vessel and its contents remain coherent and intact throughout the teleportation sequence. As the saucer approaches the portal, it encounters the Trancevable mirror interface, a non-material membrane that allows seamless entry without physical obstruction. The interface is governed by quantum entanglement and topological constraints, ensuring that the saucer's structure is preserved as it begins dimensional deflation. This phase marks the transition from conventional space into the engineered 1D slipstream, setting the stage for the core teleportation process. The interface's stability and responsiveness are vital for a smooth and lossless transfer. Upon passing through the Trancevable interface, the saucer undergoes dimensional deflation. This process compresses the vessel and its contents into a 1D slipstream conduit, dramatically reducing spatial footprint while preserving all 3D and 2D information. The deflation is managed by the dimensional compression zone, which carefully modulates energy input to avoid structural or informational loss. This phase is analogous to folding a complex object into a single thread, maintaining its essence for transit through the portal void. The saucer now in its 1D form, it enters the Slipstream conduit, a stabilized quantum channel connecting the entry and exit portals. The Slipstream is maintained by the 1D hosting layer, which shields the vessel from decoherence and environmental noise. Throughout transit, the saucer's 2D surface fidelity and quantum state are continuously monitored, ensuring that no information is lost or corrupted. This phase is the heart of the teleportation process, where distance is effectively nullified and the vessel traverses the dimensional divide. As the saucer reaches the exit portal, it undergoes rapid inflation, reconstituting its full 3D and 2D structure. The inflation interface is responsible for guiding this process, using entanglement cues and conservation rules to ensure perfect restoration. Any errors or distortions detected during this phase are corrected in real time by the control system, drawing on feedback from the quantum echo field. Successful inflation marks the completion of the teleportation cycle, with the saucer emerging intact in the new dimensional coordinate. One of the defining features of the Chronoport Lenticularis is its bidirectional portal logic. Unlike traditional teleportation systems, this saucer can traverse the slipstream in either direction, thanks to symmetric entanglement and adaptive time locking. The control system manages synchronization between both entry and exit points, allowing for reversible travel and rapid redeployment. This flexibility is essential for dynamic missions, emergency returns, or multi-point exploration. Temporal safety is paramount during slipstream operations. The saucer's control unit continuously monitors time dilation effects, echo harmonics, and energy bands to ensure all parameters remain within safe thresholds. If anomalies are detected, the system can initiate emergency protocols, such as reversing inflation or holding the vessel in the slipstream until conditions stabilize. Post-transit diagnostics analyze quantum echo decay and lattice coherence, providing detailed feedback for future missions. Quantum echo field is a unique feature of the Chronoport Lenticularis. During and after transit, the portal emits harmonic feedback, concentric waveforms that stabilize the entanglement lattice and absorb residual energy. These echoes are not just byproducts. They play an active role in reinforcing portal coherence and preventing decoherence. The field's properties can be tuned for different mission profiles, adapting to the demands of each teleportation cycle. Entanglement lattice is the backbone of the saucer's quantum synchronization. As the vessel prepares for transit, the lattice expands outward, increasing the range and stability of the entanglement field. Each node in the lattice acts as a quantum anchor, maintaining coherence between the saucer and the portal. This expansion is dynamically controlled, scaling with object mass and dimensional distance to ensure robust bidirectional connectivity. Reverb stabilization is essential for preserving the saucer's internal chronology during slipstream transit. The system deploys concentric dampeners that absorb time shockwaves, preventing temporal drift or paradoxes. This stabilization ensures that the vessel's timeline remains consistent, regardless of the dimensional or temporal distance traveled. The technology is especially critical for missions involving variable time zone locks or rapid redeployment. Inflation-deflation energy curve visualizes the dynamic energy requirements of portal transit. As the saucer compresses into the slipstream, energy spikes sharply, peaking at the portal interface. During inflation, energy is rapidly released, restoring the vessel's full dimensional integrity. Monitoring and managing this curve is vital for subsystem calibration, ensuring that transitions are both efficient and safe. Closer look at the internal portal dynamics reveals the layered structure of the porthole. The outer entanglement field synchronizes distant coordinates, while the 1D hosting layer stabilizes the vessel during transit. At the core lies the dimensional compression zone, where deflation and inflation mechanics are precisely managed. Each layer plays a critical role in maintaining coherence and ensuring a smooth, lossless transfer. Bidirectional transfer schematic illustrates the reversible flow of the saucer through the portal. Directional arrows indicate that the vessel can move from dimension A to B and back again, with all subsystems adapting in real time to the direction of travel. This capability is made possible by symmetric entanglement and dynamic time locking, setting the Chronoport Lenticularis apart from conventional one-way teleportation systems. Superpositional entanglement matrix is a sophisticated grid that enables the saucer to maintain multiple quantum states simultaneously. This matrix underpins the vessel's ability to adapt to fluctuating portal conditions, ensuring that entanglement is never lost, even during complex or extended missions. The matrix's design draws on the latest advances in quantum computing and topological codes, offering exponential protection against decoherence. To ensure operational reliability, the Chronoport Lenticularis is equipped with a comprehensive subsystem diagnostic overlay. This system continuously scans all major components, from the hull and emitter array to the time-locking core and entanglement lattice. Any anomalies are flagged in real time, allowing for immediate intervention or recalibration. The diagnostic overlay is essential for mission safety, especially during high-energy transitions or extended deployments. Operational Deployment Protocol outlines the step-by-step process for activating and utilizing the Chronoport Lenticularis. From portal initialization and object entry to slipstream transit and inflation, each phase is governed by strict safety and performance standards. The protocol also includes contingency measures for emergency scenarios, ensuring that the vessel and crew can be safely recovered in the event of system failure or environmental hazards. G-band monitoring is a critical aspect of the source's operational integrity. Sensors distributed throughout the vessel track energy fluctuations during deflation, slipstream transit, and inflation. These readings are analyzed in real time, allowing the control system to adjust power input and maintain optimal performance. Effective energy management not only ensures successful portal transitions, but also extends the operational lifespan of the source's subsystems. Managing temporal thresholds is essential for safe slipstream navigation. The source's control system maintains all operations within predefined time safety margins, preventing accidental time jumps or paradoxes. If a threshold is approached, the system can pause transit, initiate corrective measures, or revert to safe state. This proactive management is vital for missions involving variable or extreme time zone differentials. Entanglement Lattice's ability to expand and scale is a key innovation in the Chronoport Lenticularis. As mission demands increase, whether due to larger payloads or greater distances, the lattice dynamically grows, maintaining coherence and stability. This scalability ensures that the saucer remains effective across a wide range of operational scenarios, from short-range hops to interdimensional expeditions. Before and after each teleportation cycle, subsystem integrity validation is performed. This process involves comprehensive checks of the hull, emitter array, time-locking core, and all quantum systems. Any detected faults are logged and addressed before the next operation. This rigorous validation protocol is essential for maintaining the source's reliability and ensuring the safety of its crew and cargo. Chronoport Lenticularis is designed for a variety of mission profiles, from scientific exploration and logistics to emergency response and interdimensional research. Its adaptability, bidirectional logic, and robust quantum systems make it suitable for both routine and high-risk operations. As quantum technology advances, new use cases will continue to emerge, expanding the source's role in the future of dimensional travel. With great technological power comes significant responsibility. The deployment of the Chronoport Lenticularis raises important ethical and safety considerations, including privacy, consent, and the potential for unintended consequences. Strict operational protocols, regulatory oversight, and ongoing ethical review are essential to ensure that this technology is used responsibly and for the benefit of all. Chronoport Lenticularis represents just the beginning of a new era in dimensional travel. Future research will focus on enhancing quantum coherence, expanding lattice scalability, and integrating advanced AI for autonomous navigation. As our understanding of quantum and dimensional physics deepens, the possibilities for exploration and discovery will continue to grow, opening new frontiers for humanity. Conclusion: the Chronoport Lenticularis is more than a technological marvel. It's a portal to tomorrow. By harnessing the principles of quantum entanglement, dimensional slipstreaming, and temporal synchronization, this saucer sets the stage for a new chapter in human exploration. As we continue to refine and deploy this technology, the dream of instantaneous, bidirectional travel across space and time moves ever closer to reality.